All right, what we're going to talk about today is a simple, oops, let me change my ink here. Simple, keyword there is simple, stoichiometry. Simple stoichiometry. It's going to involve us looking at this problem. So if you need to pause the video and write down this problem, now's a great chance to do so. All right. In any stoichiometry problem, we need a reaction. Now, back in the day, we used to take this description and write down what the reaction was, but we don't do that anymore. So now I'm just going to write down for you what the reaction is. Okay, that's hydrogen gas. If you read it, it tells you hydrogen gas reacts with oxygen gas to produce water. So each of these things is named in the problem, so we don't have to have any confusion about what each of these things is. What's the problem with that? Of course, it's unbalanced. The first step, oops, let me move mine over just a little bit. The first step in any stoichiometry problem is balance the reaction. You need to balance the reaction. So when I come back over here, I'm going to switch ink colors. We're going to balance this reaction. I'm just going to do it. If you want to pause and practice, that's great. Oxygen is unbalanced, so we put a 2 here. But that unbalances our hydrogen, so to fix that, we're going to put a 2 there. Great. Step 1, done. Step 2. We're going to go back and we're going to do factor label. I know, exciting. Factor label. To do factor label, you have to find the starting number. And so far, we've only ever had one number in a problem. And if you look at this problem, there is only one number in this problem. So the number we have to start with is going to be the number in the problem. It's going to be 3.0 moles. Don't take any shortcuts here. Make sure you don't just write down 3.0. You need to write down moles. You also need to write down what that is moles of. That is moles of oxygen gas. So I'm also going to write down, for this problem, I'm going to write down O2. Super critical. Then you draw your line. You draw your equal sign. Ready to head to step 3. Step 3, write the units of your answer. So we're going to go, doggone it, we're not going to move that. We're going to move over here. Look out here, what answer do we need to get? How much water is produced? Now, right now, it doesn't ask me a unit. It doesn't tell me a unit, but I'm going to tell you right now, the unit you're going to use for all these problems is your answer will always be in moles. Don't stop there. Moles of what? How much water? We need to know moles of H2O. If you didn't remember that oxygen was O2, H2O was water, remember to go back to the reaction. They're always going to be in the balanced reaction that you've got. All right, now we draw a line. Step the 4th. Use conversion factors. We're going to use conversion factors until we get our answer. So, conversion factor. I need to put something on the bottom that's going to get rid of something in this number to make it look like this over here. I'm trying to make moles of O2 look like moles of H2O. And some people are like, well, you can get rid of the 2 and then add an H2, and that would make it look the same. But no. That O2 is all together. We can't just get rid of a piece of it. We got to get rid of the whole thing. So the first thing to get rid of, right, is I want to get rid of O2. So I'm going to put O2 on the bottom. What would I like to convert that O2 into? Well, if I made that O2 into an H2O, right, if I just put in an H2O right there, now this front part, this moles of O2, becomes moles of H2O. Perfect. That's my conversion. I'm going to convert from O2 to H2O. To do this, though, I need to do math. I got to have some numbers in there. We can't just do some algebra. We got to have some numbers in there. So what numbers do we need to put in there? We need to put numbers here and here. Where can we get some numbers that go in front of H2O? Where can we get some numbers that go in front of O2? They're in the equation. So the number that's right there, I'm going to put here. And the number that's right there, I'm going to put there. Drew that one a little overzealously. There we go. So it's real easy to see there's a 2 in front of the H2O, but there's a 0 in front of the O2. No, sirree, Bob. I hope you're yelling. No, sirree, Bob. Remember, it's understood to be a 1 there, so we're going to put a 1 in front of that O2. Now we cancel out the things that cancel out. What cancels out in this problem? Well, anything on the bottom and on the top gets canceled out. There's an O2 on the bottom, and there's an O2 on the top. So, gone! Gone! Those guys are gone. And all we're left with is a math problem. And we're left with 3.0 moles H2O, which is exactly what we want, right? Those things didn't get canceled out. But now we got to do this math, so I'm going to cover up everything else. I'm going to look over here. I'm going to cover up everything else. And there's a 3, a line, another line, a 2, and a 1, right? So if I concentrate my vision on those things, I should say that's 3.0, my bad. 3.0 on top, there's a 2 on top, and there's a 1 on the bottom. What does that translate into? That means we take 3 times 2, and we divide by 1. So that's how I'm going to plug this into my calculator. Again, I took a little shortcut there, didn't I? 3.0 times 2. Sorry about that, folks. 3.0 times 2 divided by 1 gives me my calculator. Plug it in. Plugging it in. Plugging it in. All right. Way too many buttons there, right? My calculator's going to tell me it's 6, and that's good enough for me. 6 moles of H2O. Some folks say, hey, why did I go through all this conversion factor? I could have just done that in my head. I could say if I start off with 3 of that one thing, there's twice as many of the water. And that's a good way to check your answer. But you're going to find as we get into next week, this gets a little more difficult. We're going to add a step each day till we build up to some pretty difficult math. I'm going to work one more example problem for you in video, and we're going to let it rip. You guys have your homework.